Hi everyone, welcome back. Hope you are doing good. This is Mahesh. In this video we will learn about merge sort. So what is this merge sort? So before understanding merge sort, first we need to understand the merging technique. So this merging technique is the heart of our merge sort. So it's very important to understand how merging happens. So basically, let us consider two arrays which are already in their sorted order, and then we want to merge both the sorted arrays. So let us take the example. Let us take a equal to maybe 1, 3, 5, 7 and 9. Let us also take another array which is B, which is 2, 4, 6, 8 and 10. So if you see both the arrays, they are already in their proper sorted order. Now what we want to do, we want to merge these two sorted arrays and get the merged sorted array. So for that, what we can do basically, so what I can do, I can take first this one and then second 2 from this array, then 3 from this array, then 4 from this array, 5, 6 and so on. So what I am trying to do, I am trying to compare elements in both the arrays and I am trying to pick the smaller element first. I am trying to pick the smaller element first. So for that, what I will do, I will place a pointer on both the arrays at the start of the element. Let us call it as I and let us call it as J. Okay, so I want to take another array which is C. Then this stores my combined merged sorted array basically. So now what I will do, I will check these two. So out of these two, which one is smaller? So one is smaller. So I'll pick one. Then what I will do, I will increment this pointer here. Okay, because I cannot leave this pointer here only. If I leave, the next comparison again I will compare with the same number. So I need to increase this particular pointer. Now I will compare these two elements. Okay, which one is smaller? This is smaller. So I'll take that element and again I will increase my j pointer. I'll keep doing this. Now out of these two, this is smaller. I'll pick this and I'll increment this pointer. Okay, so next 4. So I'll increase this pointer, j gets incremented. Now out of these two, 5 is smaller. So I'll take 5 and I'll increment I pointer. Next out of 7 and 6, 6 is smaller. So I'll take 6 and I'll increment my j. Out of 7 and 8, 7 is smaller. So I'll take 7, I'll increment my I. So out of 9 and 8, 8 is smaller. So I'll take 8 and I'll increment my j pointer. So out of 9 and 10, 9 is smaller. 9 is smaller, so I'll take 9 and I'll increment. So I points outside. When any one of the pointer points outside of that particular array, then I'll stop and I'll simply copy the remaining elements. So remaining element is this one, which is 10. Assume there are more elements here. Say for example 12 and 14. So in that case, I mean this is the best case, because when I gets exhausted, we will stop here and we simply copy the remaining element. So I will increment j. So I'll take 12. I'll again increment j and I'll copy 14. So this is my merged array. So this is how the merging procedure works. So for this one, we should keep in mind the prerequisite is both the arrays should be already in their sorted order. So that is the prerequisite. Otherwise, we don't get the proper sorted merged array. So that's why the prerequisite is both the arrays should be sorted arrays. Okay, so this is the dry run. Let us try to look into the pseudocode. So let us take merge, and it takes array A and B. For now, let us consider these two as separate array, but for our merge sort, it is little different. We will give the same array. In that only we need to tweak a little bit, but for now we will consider this, and we will make the modification when we look into merge sort. So now I have A and B, which are arrays, and they are sorted. That's the precondition. Now what I will do, I will take another variable which is C. So before that, let M be the length of array A, so A dot length, and N be length of array B. Okay, now the resultant array, which is C, it is of length M plus N. So we will take another array C, which is of length M plus N, and this holds the merged array. Okay, now what we will do, let us take two pointers, I equal to 0 and j is also equal to 0. Now while, so what we need to do, we need to iterate until either I gets exhausted or j gets exhausted. So while I less than or equal to, I will say less than m, and j is less than n, what we will do, we will compare both the element at I and j. If a of I is less than b of j, then I should take a of I, because this is a smaller element. So maybe I will take one more, k equal to 0. So what I will do, c of k is equivalent to a of I. Then increment, we will see that later, because there is another condition which is else part. Else I should take c of k as b of j. So c of k is equal to b of j. So once this is done, I need to increment my k. I need to increment, once this is done, I need to increment I here, because I am assigning a of I to c of k. Now if that is not the case, in the else part I need to increment my j. So this is the end of comparison and the merging of the element. Now if there are any remaining elements, then the remaining elements can be either in A or in B. So we don't know where exactly we get the extra elements. So for that, what we need to do, we can simply use for loop, and I stops somewhere. So I basically stops somewhere. So from there till it is less than its particular length, we will have to iterate. So I less than m, I plus plus, what we will do, we will say c of k equal to a of I. then increment k plus plus. This is for copying the remaining elements in the first array. Then use another loop, and that is basically our j pointer. It has stopped somewhere, we need to continue till the end. So from there, j less than n j plus plus, we will do c of k equal to a of j and increment our j pointer. So what these two loops will do, they will check if at all anything is left from either array A or array B, then they will copy those elements into the third array. Okay, so once everything is done, what we can do, we can simply return our C, which is merged array. So now this is our pseudocode for merge procedure. What is the time complexity? So for this merge procedure, since m is the length of array A and n is the length of array B, so since, what exactly we are doing, we are comparing and then we are copying it to our third array. So basically it is of order m plus n. Okay, this is the time complexity. What about the space complexity? Space complexity is also of order m plus n, because we are using this particular array which is of length m plus n to place the merged elements into this particular array. That's why it is of order m plus n. So this is basically the merge procedure. We will look into its program in action. Let's create a JS file, merge sort.js. Let us create a merge method which accepts two variables, which are basically two arrays A and B. Now let us take a constant m which carries length of array A, and let us take n which holds the length of array B. Now let us take two pointers, I which is equal to 0 and j equal to 0. Now let us create a while loop while I less than m and j less than n. What we will have to do, we will have to check the element at I and j. So if a of I, if it is less than b of j, then a of I is smaller. So what I will do, so before that I need another array which is, let C is an array, empty array for now. So what we can do, we can take one more variable a which is equal to 0. So now I will say C of k equal to a of I, and then I will increment I. If that is not the case, then what I will do, so C of k I will assign with b of j, because b of j is smaller in this case, and then I'll increment j. Once both are done, I will have to increment my k pointer. Otherwise, the element gets overwritten, at the same place in the C array. So once after the end of this particular while loop, so what happens? either maybe the first array gets exhausted or maybe the second array gets exhausted. So we don't know which one gets exhausted. So what I will do, I will try to copy remaining elements from the first array A and also from the second array. So I less than m I plus plus, what I will do, C of k equal to A of I. Then I will increment my k pointer. I will repeat the same thing for the remaining elements from the other array, which is j and its length is n, and j plus plus, and this should be b of j. I'll make this modification and I will increment my k. Now I will simply return my C array. Let us call the method and pass the array to see what is the output. Let us call our merge method. This accepts two arrays basically. So let us take the arrays which we used during our pseudocode dry run. So 1 3 5 7 9 is one array. The other one is 2 4 6 8 10 12 and 14. So this is it. Now let us try to run this particular merge.js. So I will use node merge.js file. So this will give us the merged array. So if you see here, it is 1 2 3 4 5 6 7 8 9 10. After that, the remaining elements, I mean after 9 it will copy the remaining elements to the array. So 10 12 and 14 are copied after that. So this is how, I mean, we merge two sorted arrays. Now let us look into this merge procedure. If at all we have only single array, but the thing is half of the array is sorted and the next half of the array is sorted. But if you look into the full array that is not really sorted, let us look into an example here. Maybe this is one array. So let us say I have 2 4 6 and 1, maybe 3 and 5. So if you see this array, so this is sorted till here, okay, and this is the remaining part is sorted. Now what I want to do, I want to take these two arrays as two arrays and I want to merge them. So if I want to merge them, what I will have to do, I will have to keep a pointer here and I will have to keep a pointer here. Okay, then I need to repeat the same merge procedure. So I will compare these two. This is smaller, I'll take and I'll increment this. I'll compare these two. This is smaller, I'll take 2, I'll increment this. I'll compare these two. This is smaller, I'll take and I'll increment. And this, out of these two, this is smaller, I'll take this, I'll increment. This is smaller, so I'll increment, I'll stop here, and this is the remaining element, so I'll take and I will place it. So this way we get the sorted merged array. But I want to do this step here in the same pseudocode. So here we used two separate arrays, but now that is not the case. I have only one array, which is A. So if that is the case, then what I should pass along with this, what is the lowest element, what is the mid element, and what is the highest element. Okay, so three things I should know, because my first pointer points to here, which is the low, and my second pointer which points here, which is one place after my mid, and this is my mid. My mid is nothing but the length of first array, and this is my height. Okay, so with this what I will get to know, low to mid is my first array and mid plus 1 to high is my second array. So what I will pass low, mid and high. So these three parameters I will pass here in the same pseudocode. Then what I will do, so maybe my M will be mid. Okay, and my N will be, mostly we will take it as high only. Why high? Because its first value starts from mid plus 1, so its highest length is high. So I will change these two, and this C will be the length of array. So basically length of A. Now my I points to low and J points to mid plus 1, and my K points to my low because it is starting from here. So I will have to copy the element at the same position into the new array. So my K will be low. So this is the change, and then this will continue as it is. And what I need to change after this, so K will be pointing to this. Yeah, this is sufficient, I think. So with this, I mean, we can merge two sorted arrays, the part of array basically. I mean, they are part of the same array, but part of it is sorted, mostly half of it is sorted, and another half of it is sorted. But if you combine everything, it is not sorted. So we will use this particular logic to sort such array. Okay, we will, so at the end we get this particular array which is merged and which is properly sorted. Now what we want to do, we want to replace our original array with these elements. So what I will do, instead of returning C, what I will do, maybe I will write it here. So I will start from for I equal to 0 to n, I equal to 0 to n. I have to move these elements into my array. So A of I equal to C of I. So if I do this, what it will do, it will replace my elements into my original array. So finally what I can do, I can simply return A, or even if we, I mean, we really don't need to return A. Since our original array A is only getting updated, so we can simply access this A after the sorting is done in our calling method. So that's not really required, but for or we can simply remove this and we can end this particular pseudocode. So we will look this pseudocode in action in the real program now. Let's modify this merge method with a single array. The assumption is half of the array, that is from low to mid, that is sorted, and the next half of the array is sorted from mid plus 1 to high. But if you see the entire array, I mean, that might not be in a proper sorted order. So let's make the modification. So we will pass low, mid and high values here. Then we don't need this particular line. We will directly use low, mid and high values here. So we will see I starts from low, and j starts from mid plus 1, and k as usual it starts from 0 because it's a third array which we want to place the values from uh, both the arrays after comparison. So now let us check whether I is less than or equal to mid, then j is less than or equal to I. So with this modification, this works fine. So we will do one more small modification because we want the original array back. So we really don't need the return statement. So we can remove this one. But once after merging is done, now we have elements in array C, but we need these merged elements back to array A. So for that, what we will do, for let I equal to 0, I less than maybe I, and I plus plus. So instead of I, we will take C dot length here because we are taking reference from third array. Now what we will do, we will copy them back to our original array. So our original array, basically here we are trying to merge from low to high. So what I will do, I will take low. For that I will add I, and then I will assign the value from the array C. So this way, I mean, it will replace the values in array A, and this low is because, so here, I mean, we are taking an example where the low starts from 0, but it might not be true. I mean, in our merge sort case, I mean, this low can be anywhere on the left half or on the right half. So which we will look into it later. But for now, I mean, we will do this. And once this is done, what we can do, we can simply save this, and we will make some modification in this particular merge method. So since we need only one array, so we will take 10 elements. Basically, this is the left 5 elements, and these are the left right 5 elements. So I'll remove these two, and now with this I also want to send low, mid, and high values. My low is 0, and my mid is somewhere it is 4, 0, 1, 2, 3, 4. This is 4, and my high is 9. So if I send this one, and if I execute merge sort, so we see that, I mean, B is not defined. So for that, we also need to make some more modification here. So instead of A of I, we should take it as, instead of B of J, we should take it as A of J itself, because we are getting the elements in the same array. There is this modification also which is required. So with this, mostly I think we have replaced all the B's. So let's save. Still we don't get the desired output. So if you see, M is not defined. So maybe this is our mid, and this should be modified as I is less than or equal to, and this is J is less than or equal to I. So we missed these two conditions. So with this modification, let's run it again. There is one more B here. I'll replace that. Let's run it. So we get undefined because here we are passing the values and we are not returning anything from this particular method. So what we can do instead, so I will simply take out this, and I will assign it to maybe array A, and then I'll assign these values. Then I will call my merge method, but I don't pass that inside console log. I will pass it outside. Now I will print my A. So since A is getting replaced after the merge with the merged values from the third array, we should have the merged values in array A itself. So now if I run, we will get the proper merged values 1 2 3 4 5 6 7 8 9. So that's it for this video. Thanks for watching.